Today we're going to run through a quick tutorial on how to assess for pneumothorax using point-of-care ultrasound. Thanks for your time. You may be wondering, why ultrasound? I got a guy, he can take a picture for me. Sure, it may take a while, and he may grumble about the order not being in, but it seems to work out okay. Well, let me give you 3 reasons. First, the supine chest x-ray, our current standard, has terrible sensitivity. Ultrasound? Not terrible. Second, this scan is quick. It should take less than a minute. And third, it's easy to do. I think I can teach you in about 5 minutes. We'll start with our high-frequency linear array probe. Put some gel on the probe and place it on the anterior chest wall. When you do, we should see something that looks like this. Now, don't worry, I've drawn a schematic. Here it is. In the near field, you'll see the striated tissue of the chest wall. Deep to that are the black circular ribs, followed by the rib shadows. Just beyond the ribs are the visceral and the parietal pleura. You can identify the pleura using the ribs as a landmark. Here's the same thing on the actual image. Chest wall, ribs, rib shadow, and the visceral and parietal pleura, the bright white line. Now that we know what we're looking at, what are we looking for? Our air-filled lungs are covered by a serous membrane, which doubles back on itself to form the visceral and the parietal pleura. The potential space between the visceral and parietal pleura is normally filled with small amounts of physiologic fluid. As this fluid and the pleura move, we can see the artifact from the movement of the opposing pleural surfaces and the pleural fluid. We are looking for 2 artifacts. The first is lung sliding. Ultrasound cannot identify a single pleural layer, but the relative movement of these layers is seen as a shimmering or a twinkling, or has been described as ants walking on a log. If there is a pneumothorax, the air inside the pleural space will scatter the ultrasound waves, and you will not see lung sliding. You will only see one pleura. The second artifact is comet tails. Comet tails are white linear artifacts that extend from the pleural line down into the lung. They are the result of reverberation artifact. If you see comet tails, the 2 pleural surfaces are in contact with each other, and there is no pneumothorax at this level. If you see lung sliding or comet tails, there is no pneumothorax at that level. Again, if you see lung sliding or comet tails, there is no pneumothorax at that level. If instead you see a flat pleural line, this suggests that air is in the pleural space and a pneumothorax is present. In pneumothorax, air enters this potential space and scatters the ultrasound beams before hitting the physiologic pleural fluid or the second pleural membrane. If you do see a pneumothorax, confirm it by stepping into M mode. M mode is a way to visualize structures as a function of depth and time. The structures that the white line passes through on the top image here are represented on the bottom image as a function of time. Usually, the brightest horizontal line on the bottom image represents the pleural line. Presence of motion is seen as incoherent noise, and the absence of motion is seen as straight horizontal lines. So if you're scanning your patient, you put the probe on the chest, and you see lung sliding or B lines, be reassured, but confirm it. Step into your M mode, where you will generate an image like this. The motion of the pleura are seen as noise, giving it the sandy beach look. Beaches are good. If you see a beach, there is no pneumothorax. If instead, you put the probe on the chest, and you see a flat, white pleural line, no B lines, no lung sliding, this suggests there's a pneumothorax. Again, confirm it. Step into M mode and generate an image that looks like this. Now again, the absence of movement is seen as horizontal straight lines, giving it the stratosphere sign, looking sort of like a barcode. Stratosphere is bad. It's hard to breathe up there, like with a pneumothorax. When you identify a pneumothorax, the next step is to attempt to quantify it. Move the probe posteriorly to identify where the normal pleural interface contacts the boundary of the pneumothorax. Here's a CT image to help you visualize it. If you imagine putting your probe where you would initially anteriorly, you see the pneumothorax. As you slide it posteriorly, you can find the interface where the normal lung and the abnormal lung run into each other. Here's a schematic to show you what you're looking at. There's air in the pneumothorax, there's normal lung, and the intersection between the two is what we call the lung point. This is the most sensitive sign for a pneumothorax. And this is what it looks like on the ultrasound image. You can see that lung sliding coming in and out of the screen as the patient's breathing. Now once you find that lung point, the farther posterior it is, the bigger the pneumothorax is going to be. There are two important mimics of the lung point. The first is the lung interface with the heart in the left chest. This can be mistaken for a lung point, but is given away by the fact that you can see the beating heart in the far field. The second is the inferior edge of the lung at the diaphragm. The interface here is given away by the solid organ density of the liver. Let's sum up. Ultrasound is sensitive, it's quick, and it's easy. I think it's definitely worth your time to learn it. To generate the images, we're going to use our vascular probe. We're going to put some gel on it. We're going to put it on the anterior chest wall. We're going to identify the pleura using the ribs as a landmark. And once we find our pleura, we're going to look for the normal signs of lung sliding and comet tails. If we see those two things, we know that the pleura is in contact with itself. We're going to confirm this by slipping into M mode and then trying to find our beach sign, which shows the normal motion, which is interpreted as a grainy image in the far field. If we see a pneumothorax instead, we'll look for the barcode sign when we confirm in M mode. Once this is done, and if we identify a pneumothorax, the final step is to quantify it by placing the probe increasingly posterior on the chest wall, trying to see how big that pneumothorax is. That's it. That's all. So I hope this is useful to you, and I am open to any suggestions for how I can make this better for you guys. Take care.